On number 22, we're given the picture here with the points R, S, and T on it. The coordinate of R is 6, the coordinate of T is 20, and we want to know what RT is. Now you have to know what this means. When we write the letters R and T back to back, that means the distance or length of segment RT. Well, to find distance, all you do is subtract coordinates. That's 20 minus 6. As long as you subtract right to left, the point on the right minus the point on the left, it will always end up positive, and you won't have to worry about absolute values. But technically, it's the absolute value of 20 minus 6. That just guarantees you that if you had subtracted it backwards, 20 minus 6 in absolute value would be the absolute value of negative 14 equals 14. But as long as you remember to subtract right minus left, you can ignore the absolute values. On problem number 23, the same 3 points, so your answer if that last one was 14, same 3 points, different coordinates, and one more thing. This time R is at 3, T is at 19, and S is the midpoint. That means it's right in the middle between S and T. So if I let M be from midpoint, we have a rule that says to find the coordinate of a midpoint, you just end the endpoints and divide by 2. M is 3 plus 19 over 2. You're just averaging the ends to get the middle. And this is 22 over 2. We get 11 for problem 23, part A. On 23, part B, we have the same value for T. S is still the midpoint, but this time we know what S is. This time S is 6, and we're out to find the coordinate here at R. I'll just call that little r. Well, you have 2 ways you can go about it. You could use the formula again. The midpoint, 6, equals R plus 19 over 2. If we would multiply, this would be 12 is equal to R plus 19. That gives you that R is negative 7. The other way to get that negative 7 is to just use the fact that the middle is the same distance to both ends. So you say, well, what do I do to get from 19 down to 6? And the answer would be to go from 19 to 6, I'd have to subtract 13. So if you simply subtract 13 more, you should be at the other end, and 6 minus 13 is that same negative 7. On problem number 24, on number 25, the dot representing a city on a map would be an example of a point. Number 26 says the non-common sides of 2 adjacent supplementary angles. Well, you'd have 2 adjacent supplementary angles when you're dealing with a linear pair. If I call them angles 1 and 2, angles 1 and 2 are the type of angles we're talking about there. Supplementary means they add to 180. We know that because they form a linear pair. The non-common sides would be, I'll leave one of them yellow and make the other one purple, or whatever color this comes out to be. The yellow line and the yellow ray and the purple ray are opposite rays. They are not perpendicular. So number 26 is a false statement. Number 27 says that the RT is the same as TR, and that's true because they both mean the length of the segment that goes from T to R. Number 28 talks about angle SPW being the same as angle SWP. And that's not true. The letter in the middle is the vertex of the angle, and angles with different vertices are not the same angle. Number 29 says angle P is a valid angle name in figure 1. That's a false statement because every angle in that picture has a vertex at P. We would not know which angle you are talking about. Number 30 says supplementary angles are angles that add to 90. That's false. Supplementary adds to 180. Number 31, vertical angles are never adjacent. That's true. Let's real quick draw a picture of vertical angles. Vertical angles occur where two lines can totally cross. They're the angles across from each other. Now, to show that they are not adjacent, adjacent angles are defined to be angles that share a common side. Oops, missed that guy a little there. This angle I've just drawn, and the angle I'm going to draw in yellow, its vertical angle on the other side, they do not have a common side, so they are not adjacent. So they are never adjacent angles. Number 31 is true. Vertical angles are always complementary. That's false. They are always congruent. They could possibly be complementary if they were both 90s, but that would be the only case. Nope, they could never be. Let's think about this. I guess if they were both 45s, they're both 90s, they'd be supplementary. Okay, a 35 degree angle is acute. That's true. Number 33 on vertical angles is a false. Number 32 on vertical angles is a false. Number 33, a 35 degree angle is acute, is a true statement because it's between 0 and 90. Number 34, lines that intersect to form a right angle are called perpendicular. Yes, that's true. That's the definition of perpendicular lines. And number 35, two angles in a linear pair, that's side by side along a straight line, like angles 1 and 2 there, are always add to 180. That's true. You'll see a much better picture of the three-dimensional box that's on your back when you look at your figure page. But this is supposed to be the same drawing as the figure number 2. And it says we want to name a point that is coplanar with the points A, C, and G. Now A, C, and G, if I highlight where they are all down along the floor of this box. Coplanar means in the same plane with, so it would be the point E that's in that same plane. So E is your answer. On number 37, we want a point that is not coplanar with A, B, and C. A, B, and C are on the back of the box. D is coplanar with them, so anything but D works. F, H, G, or E, any of those are good answers. And on number 38, we're looking at plane HFB. That's H back in the corner there. Oops, wrong direction. H is up in this front corner. HFB is the top of the box. And we want to know what plane, along with it, intersect in line HF. Well, HF is this guy right here in the front that I've just put in there. And the plane that contains that guy would be FHGE. So you want to look at the letters FHGE and choose any three of those letters. Any three from that list will answer number 38. Number 39 is the symbol for array. That's choice A. Number 40 is the symbol for a line. That's choice C. Number 41 is the symbol for a segment. That's choice D. And number 42 would be the length of segment AB. That's choice B. On number 43, it says the measure of the complement, measure M comp, the measure of the complement of angle A is 6 more than 5 times angle A. And we're supposed to find the measure of angle A. Well, there's more than one way to do this, but the way I'd given you in class is always let x be the angle. So we're going to let x equal the measure of angle A, the one we're trying to find in this case. Now, we also have its complement involved. That would make 90 minus x equal to the measure of the complement. If that was the approach you'd use, then the words of the problem say the measure of the complement, well, that's the 90 minus x thing that we've just named, that's equals 6 more than 6 plus 5 times the measure of angle A is x, 5x. If you solve that, you're going to get x being 14 degrees. Now it wants us to use a full sentence to answer the question. Be careful, please answer the question asked. The question says find the measure of angle A, so you should say the measure of angle A is 14. You could say degrees. But if you just at least just said 14, that would be fine. There are other ways to approach that problem. That is not the only one. I'm going to erase down here this solution and show you another one. I really like the previous approach that I did on this problem, but another totally valid way to do this would be to say, well, let's let x be the complement. You just need to know what your variables stand for. In that case, the measure of the complement is, I'm going to retract my last statement here. We're still going to let angle A be our x in this particular solution. So we'll still go with x equaling the measure of angle A. Now if you read the sentence up there, the measure of the complement is, that's equals, 6 more than 6 plus 5 times the measure of angle A would be 5 times x. Now, we haven't used the fact that complementaries add up to 90 yet, so you could say x plus 6 plus 5x equals 90. Here you would have that 6x equals 84, and we'd still get that same 14 that we got doing it the other way. Either way is a good way to solve the problem. Alright, number 44, we're getting close to the end. It's good because we got a lot of time in these videos here. Okay, we've got this picture of an angle split into two parts. The angle on the outside is angle ABC, and it's split into two parts, which would be angle ABD and angle DBC. Okay, on number 44, we're told that ray BD bisects angle ABC. Bisect means divides into equal parts for angles the same way it does for segments. And we're told that ABD is 5x plus 4. That's the top half up there. And angle DBC is 28 plus x. Well, if those two are the same, are equal, then we're going to set those expressions equal to find the value of x. We're going to have that 5x plus 4 equals 28 plus x. That will give us that 4x equals 24 and x equals 6. Whoops, did something wrong there. Let me check my work real quick. Oh, I got it. When I wrote down the problem, I wrote down this part over here as a plus when it should have been a minus. That will change our answer, and we'll fix all that. The parts are still equal, but on the second step I should be adding the 4, and I'll have that 4x is equal to 32. And dividing by 4 we'll get x equals 8 for the correct answer. On problem number 45, we no longer have the bisect information, so the two angles that are inside angle ABC this time are not equal. We know that angle ABD this time is 7x plus 2. We know that angle DBC is, oh my. Okay, I apologize for problems 44 and 45. I have the pictures drawn correctly now, and I'm going to redo those. Sorry about the earlier efforts. Okay, on number 44, I've got the given information shown here. We still know that ray BD bisects angle ABC, which means it divides it into two equal parts. Now, if the whole big angle ABC, the one on the outside, I'll highlight that in yellow. This yellow angle on the outside is 72 and is being divided into two equal parts. Well, that means that the two equal parts must be 36 degrees each. So that 5x minus 4 has to equal 36. And when you solve that, you'll get x equals 8. On number 44, here's our picture. We don't have the bisect information, but we know the two parts of the angle. We know that this angle that I'm highlighting in yellow, its measure, plus the one I'm about to highlight in red, and they share a side down the middle, together they make up angle ABC, so the two parts have to add up to the whole thing. So your equation will be 7x plus 2 plus 28 plus x equals 62. And when you solve that guy, you're going to be getting that x is equal to 4. On the next one, you're asked to find the distance between these 2 points. So your distance formula was on your formula sheet. So d, the distance, is equal to a big old square root. It's the square root of the x values, 7 and 2 subtracted, 7 minus 2 squared, plus the y's, that would be the 19 and the 7 subtracted and squared. So this ends up being the square root of 169, which is 13. Number 47 asks for the number of sides that a pentagon has. The answer is 5. Number 48, the sum of the lengths of all the sides of a polygon is called the perimeter. Answer B. And the diagram of a concave polygon. Well, there's a lot of them, but they all have the property that they sort of go back into themselves, if you will. The technical definition is that it is a concave polygon is if at least one of the sides has the property that when you extend it, it goes into the inside of the polygon. So that guy is concave. And that's it. Study this, redo your practice test. Good luck on the retest.